Welcome to The Explainer. I'm your Cambridge exam strategist, and today we are tackling the absolute ultimate challenge in IGCSE additional mathematics, syllabus code 0606. We're talking about the exact topic that haunts students' dreams, using differentiation to find stationary points. Think of me as the John Wick of the grading system. You know, when the exam pushes you completely out of your comfort zone with a complex calculus problem, you need to push back. And you do that with perfect, impenetrable answers. Look, a lot of students look at finding dy over dx, setting it to 0, and determining coordinates as a purely mechanical task, just crunching the numbers, right? But there's a hidden layer here. There's a structural demand that Cambridge examiners are fiercely grading you on. So get ready, grab your notes, because we're going to deconstruct exactly how to secure every single mark on these high-stakes questions.
Right off the bat, I want to show you an urgent examiner alert pulled directly from the principal examiner report. It literally says, candidates consistently confuse key terminology and use the wrong approaches for the wrong contexts. Let that sink in for a second. Students are losing incredibly easy marks, and it's not because they don't know how to differentiate a polynomial. It's simply because they don't give the examiners the structured reasoning they demand. They're doing the raw math, sure, but they completely fail the communications test. If you're just crunching numbers and throwing them onto the page without clear logical steps, you are actively throwing your grade away.
Okay, let's dive into this. Here's our examiner's playbook for today. First, we'll cover the stationary point trap. Second, decoding assessment objectives. Third, the procedural framework. Fourth, the method mark strategy. And finally, examiner insights and evaluation.
Let's kick things off with Section 1, the stationary point trap and avoiding the top 3 examiner-flagged mistakes.
So let's look at the exact traps where the vast majority of students fail when navigating syllabus code 0606. Here are the top 3 exam mistakes extracted directly from those examiner reports. Number 1, using the wrong approach for the specific context. What does that mean? Well, for instance, a question asks you to find the coordinates of a stationary point. You find the x value, great, but then you totally forget to substitute it back into the original function to find the y value. Number 2, forgetting to check format and presentation. This basically means skipping your working out. You're jumping from the derivative straight to the roots of a quadratic equation without actually showing the factorization. Examiners hate that. And number 3, providing answers that ignore the given context. If a question is modeling a real-world scenario, say maximum volume or minimum cost, and you leave your answer as a raw coordinate without stating the maximum volume is 50, you instantly lose the final contextual mark.
And honestly, this brilliantly illustrates the 2 main types of students who fall into these traps. On the left, we've got Alex. Alex overloads answers with raw math facts. Alex is the one who will differentiate perfectly, find the second derivative, calculate roots, and then just leave a massive wall of numbers, with 0 analysis, 0 labels, and absolutely no final statement. The examiner literally has to go hunting for the answer. Then, on the right, we have Sam. Sam's trap is rushing the process. Sam sees the word stationary point, finds dy over dx, equals it to 0, gets the x value, and just stops. Sam completely misses the command word requirement that usually says something like determine its nature, which means Sam completely forgot to do the second derivative test. Whether you're an Alex or a Sam, poor formatting and rushed reading destroy your grade potential.
Moving right along to Section 2, decoding assessment objectives and unlocking the cognitive domains.
To stop being an Alex or a Sam, we really need to unlock the cognitive domains that Cambridge actually tests. You aren't just being tested on rote knowledge, you're being tested on application and critical analysis. Cambridge explicitly prioritizes analytical depth over superficial breadth. Now, superficial breadth is just crunching the numbers. Analytical depth, on the other hand, is logical, structured reasoning. When you set dy over dx to 0, you aren't just doing a magic math trick. You're conceptually stating that at a stationary point, the gradient of the tangent to the curve is horizontally flat, hence 0. So, literally writing at stationary point dy over dx equals 0 right before your calculation shows the examiner you possess analytical depth. You understand the why, not just the how.
So the absolutely crucial point here is how we structure that reasoning. Enter the PEEL framework. Point, evidence, explanation, link. Now you might be thinking, wait, isn't PEEL just for English or history essays? Absolutely not. In mathematics, it's your secret weapon. Point. You state your mathematical principle. To find the stationary point, dy over dx must equal 0. Evidence. Show the differentiation. dy over dx equals 3x squared minus 12x plus 9. Explanation. Solve it out clearly. 3x minus 1, x minus 3 equals 0, so x equals 1 or x equals 3. Link.
Connect it back to the exact question requirement. Substituting x into the original equation, the coordinates are 1, 5, and 3, 1. It's a completely bulletproof system. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's get into Section 3, the procedural framework, building the blueprint.
Now that we have the theory, we are transitioning into the live transformation phase. This is where we learn to turn flawed, disorganized answers into perfect, mark-securing responses. We need a blueprint, and this right here is your 5-step systematic memory hack. This is the exact action-oriented sequence you need to deconstruct any stationary point question. Step 1. Identify key elements. What's the function? What's the command word? Is it asking for coordinates or just the x value? Is it asking for the nature of the turning point? Step 2. Apply relevant principles. Decide if you need to use the product rule or quotient rule depending on the function. Step 3. Execute with clear working. I mean it. Show every single algebraic step. Step 4. Verify results. Did you find both x and y? Did you test the second derivative correctly? And Step 5. Present format. Use clear notation, proper brackets for those coordinates, and a final conclusive sentence if a real-world context is involved.
I want you to challenge yourself right now. Imagine a question asking you to find the nature of the stationary point for y equals x cubed minus 3x. Take 60 seconds mentally to run through those 5 steps. Identify the need for a second derivative. Apply the differentiation twice. Execute the working to find x equals 1 and negative 1. Verify by plugging them into the second derivative. Present clearly whether they are maximums or minimums. It really takes practice to make this automatic. Stop scrolling. Subscribe to our YouTube channel Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Awesome! Moving into Section 4, Method Mark Strategy. Welcome to the interactive workshop.
We absolutely need to talk about method marks. In Cambridge exams, method marks are your ultimate safety net. They reward the process of extracting data and executing clear notation, even if you make a silly arithmetic error at the very end. Here's your first challenge. When you're given a complex function or a data table mapping out gradients, you need rapid data extraction. If the gradient transitions from positive to 0 to negative, what is the core trend? You should instantly recognize that as a local maximum. If it goes from negative to 0 to positive, it's a local minimum. Practicing this visual scan under pressure ensures you don't panic when you see completely unfamiliar numbers. You're just looking for the underlying mathematical behavior.
Now for Challenge 2, Finding the Flaw. Look at this massive examiner warning. Candidates consistently confuse key terminology. Always define terms before using them in extended responses. So, what's the flaw when a student writes turning point instead of stationary point? Well, the terminology really matters. While all turning points are stationary points, not all stationary points are turning points. Think about it. A point of inflection is stationary. The gradient is 0, but it doesn't actually turn back on itself. So if the question asks you to prove a point is a stationary point and you just call it a turning point without proving its nature, you lose marks. Always use the precise language demanded by the syllabus code. Finally, Section 5, Examiner Insights and Evaluation, the final system.
Here, we're focusing on the highest cognitive domain, evaluation, comparative analysis, and identifying limitations. When questions get incredibly tough, usually at the very end of the paper, this is exactly what separates the top grades from the average. Notice how this matrix breaks down higher-order evaluative mathematical arguments. Sometimes you're asked to compare 2 different functions or models. To do this properly, you need a comparative analysis framework. You must identify similarities and differences. For instance, both functions have a stationary point at x equals 2, but one is a maximum and the other is a minimum. You must use appropriate connectives, words like whereas, conversely, or in contrast. You must support each comparison with specific numerical evidence derived from your own differentiation. And finally, you must draw a conclusion about their relative importance in the context of the question. Following this structured matrix absolutely guarantees top grades.
So, let's summarize the ultimate answering system. 3 rules for top marks. Rule 1. Command word decoding. Know exactly what show that, find, calculate, or determine the nature actually require you to do. Rule 2. PEL framework application. Structure your math like a logical argument, not just a scramble of numbers. Rule 3.
Time management matrix. Allocate your time based on the marks available. Do not spend 10 minutes on a 2-mark differentiation. Implementing this matrix consistently is what pushes average grades to the top tier. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by.
I want to leave you with this provocative thought as you prepare for your next study session. Are you just finding the answer, or are you actually proving the method? Remember, the examiner already knows the answer. They want to see if you possess the rigorous, logical mind capable of proving exactly how you got there. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.